Welcome. I'm Speed at the bottom of the helix. We're doing another September NMRAx update, monthly update, and it feels almost like a lifetime we've not been here. Thank you for an awesome convention here in DFW to distract us a little bit from all this fun. Well, our first presenter has been a train and model railroad enthusiast since the late 1950s. He enjoys building his own structures, turnouts, and other complex track work for himself, and listen to this, for others as well. He's currently building an HO scale layout of the main Central Railroad's Mountain Division circa 1950. Two levels with the top ready to haul freight. Please welcome Bill Huebner.
Good evening. Thank you, Speed. What a wonderful introduction. Um, yeah, and I help others, but I have to get hot food in return. I work for food, so pretty simple. Um, but again, good evening, everybody. My name is Bill Huebner, and I'm going to be talking about a different way of controlling our turnouts and our model railroad layouts. I've been doing this for decades and have tried pretty much everything, all the different products that are out there. And today I'm going to talk about what's called a bullfrog, and that's a manufacturer's name, not my name. And this is what they look like. Um, there's a company called Fast Tracks, and you can see the website there. It's run by a gentleman named Tim Waris. Bought many of their products over the years. Great company, wonderful customer service. Again, I'm not getting paid for this. I'm just a customer. I just work here. Um, but anyway, this is one of their offerings, and it's a simple lever switch machine, and it also has electrical switch in there as well. But it works as a fulcrum, and it locks in place if you move it back and forth. And they come as a kit. I'm going to be showing you more of this here. Let me come back here. It comes as a kit, and you build it up, and so as a result, it's actually made out of I think it's like 2 or 3 mil plywood that he laser cuts and then you glue together. But before I show you more about that, this is kind of the outline of what I'm going to be talking about. Um, Part three, I've got a whole bunch of notes, and really, so you don't have to write a bunch down. It's mostly in there. And what I do is I actually write notes to myself or manuals to myself, and that's basically what this is. Over the years, if you do something, I find that I forget how to do it 6 months later. So I basically write myself a little manual on everything I do. But this is kind of the outline of what we're going to be talking about. Um, I'm going to talk, before we get too far into the bullfrogs, I want to talk about different ways of wiring turnouts as well. So I'm not going to spend all the time just on the bullfrog, but a couple of other things that apply to any way of controlling a turnout. Also, there's um, tons of information. In fact, the manufacturer, Tim, has a number of wonderful videos on his website that kind of shows you how to build these, put them together, etc. So, and I'm not going to cover all that. He does a great job with that. What I'm going to show you is how to install them, and also some of the changes or improvements I think that I've made to the entire system, or just a different take on it. Again, you can buy them in sets of three. Unlike other uh, uh, devices, you got to actually build these, but as a result, they're cheaper, um, and they work really well. I've got about 100 right now installed. And years ago, probably as soon as these came out in like '05 or so, I helped a friend of mine. And unfortunately, he's no longer with us. Dewey Norton. He had bought these just to try them out, and to help him out, I actually took the kits home and built them and brought them back the next week. And we had them in his layout for I think 10 years. And he said, Bill, they never didn't work. They always worked. In fact, they're the most reliable type of system he had. And again, these things switch both mechanically and electrically on the polarity. And again, this is what they look like. It's kind of a quick off their website what it looks like. Again, made out of plywood, and you glue it together. this is some other products they've got where if you've got some tight spaces, you can kind of break it apart into two parts and put it wherever you need to. I haven't needed to do this so far, so that's helped me out quite a bit. Um, this I build my layout in modules, as you can see. I think this is about 4 foot by 18 inches, which is kind of my standard module size. And I don't like, and I've done it before. I don't like working on the floor, reaching up, putting switch machines in. And I've used everything under the sun, including the old twin coil. I spent way too many hours trying to make those work. But here I'm working at a workbench, and in this picture here, this is the actual bullfrog here that's sitting beneath the turnout, and this is the actuating rod. And I'm going to show you how to build that, and I make this handle as well. We'll show you that. And one of the advantages with the bullfrog is unlike, say, some of the slow motion type machines and other switch machines, I'm not, other than wiring the frog, there are no wires involved. There's no electrical switches to push. And as a result, it forces your operators to kind of move along with the train as a brakeman or a conductor would, and switching it at that particular location. But again, this is just an overview picture of where we're going to get to. Um, this is what one of the kits looks like. It just comes as uh, a bunch of pieces and you glue it together, and it looks difficult, but if you do one or two, suddenly you can do them in your sleep. You can listen to music, watch TV, whatever. I put together, I probably got 140 of these built. I can't, didn't take that long. Um, and but this is what kind of the basic kit looks like, and it gives you all the hardware. It gives you everything you need to make it work. But this is the wood portion of the kit. And the other thing it does, and we're going to review some of this stuff. I know many of you may know this, but with an all metal turnout, you've got to change the polarity of the frog. Um, Otherwise, you can have a short. So in this instance, and the bullfrog does this. There's an electrical switch in there that switches as you move the lever, and it can change the polarity for the frog. And in this instance, the frog is right there, and you can change it. Um, and that's real. It's critical. I mean, if you've got kind of a completely isolated frog, you may not need to worry about this. But it does give you this, and I'll show you more about how I actually wire all this later on. Again, this is the basic idea of how frogs are wired. Just gives you an idea. And now with DCC quote unquote friendly turnouts, the closure rail and the stock rail need to really be the same polarity, and you're just going to change the frog. Um, One of the things that I do a little differently, like in this picture, the frog's short. It's maybe 1 or 2 inches long, depending upon the scale and the size of your turnout. But I don't do it that way. I actually use the ends of the rail coming off the frog, and insulate those 2 points. It's not the standard way of doing it, and I'm not saying you should do it. But if you build your own switches, you're able to do this, and it actually cuts down on the number of joints and solder joints you have to have. So this is what I do, but show you more. Again, some of the things, best method, I just wire every rail is soldered to something. I do not rely upon rail joiners. I do not solder wires to rail joiners for a number of different reasons. I use rail joiners just for mechanical purposes, not to conduct electricity. And if you're building it, it's not that hard to drop feeders, and it's really frustrating to go to a layout and there's not enough feeders. So what I do is I just insulate at the end of the switch, and the frog becomes much bigger. And here, I call it the non-traditional way of doing it, there's 6 solder joints, one for the frog and two for the two stock rails, so to speak. And then they're insulated at the end. The traditional way is to have kind of the frog is separate, and um, and this way you've got more joints, or more solder joints to put in. Again, you can do it that way. And if the manufacturer gives it to you this way, well, of course, then you got to do it this way. And again, doing it my way with the non-traditional way, if you got a crossover, it becomes even more. This is the number of joints you got versus this is what you're going to have to do with a crossover. There's more involved, more things to do, more things to mess up, but just something to think over that I've never seen anybody else talk about. Um, and this is like how I basically build my turnouts using the fast track jigs. Is I don't normally people would put the would cut through here and isolate the frog, and that's fine. Um, Particularly if you're sure your engines you can cross this, then maybe you don't even have to power the frog. But I actually insulate it out here instead, and this whole piece then this whole frog piece gets changed. And I like it because I don't put joints here, and by cutting this, it makes this turnout mechanically less stout. It's a little stronger this way, so I try to keep it together, and I isolate just at the end of the where it's indicated. But again, if you got to make your own in order to do that. This is, as I mentioned, this is kind of just an outline of the sequence of installing the bullfrogs and putting turnouts in. And I'll start with making sure the throw rod has a number 56 hole in the center of the throw bar. You need to do that ahead of time because that's going to help you locate the turnout and the hole that you're going to need to put the actuating rod. And again, I'm not going to go through this, but it's here, so you can come back and look at this and make copies of it as you want. Um, the key too is that you can't put the turnout in and make it permanent, like glue the turnout in, and then try to drill a hole to actuate it. You got to put the turnout down, take it off, drill the hole, then put it back, and then install the bullfrog from below. And again, these are um, the procedures. And I use a 1/4 inch hole below the throw bar. We'll cover all that. Again, these are just the procedures you need to go through one by one by one. These are my own notes. Um, and I use number 18 wire to wire everything up. I'll show you that as well. Um, the fast track itself, this is kind of their standard way of controlling the bullfrog. At the end of the bullfrog, they give you this. This is part of the kit, and you attach that to these uh, uh, RC cables, and they have kind of a knob. I just don't like the feel of it. My friend again Dewey had that, and I just didn't like the feel. They work though. There's nothing wrong with it, and they sell you all the parts, or you can go to an RC store and get the cables. They're not that expensive, and the advantage is uh, you can bend them. You can, in fact, we had it where you were controlled it at 180 degree. It made a whole half curve, come back and switch it. So this is a standard way of doing it. So we're going to start locating, how to get the turnout. The first step is locating the turnout on the layout. And what I do is I have a design. I have like basically a blueprint, a computer design of all the turnouts. So before the turnouts are the first thing that go in, and I cluster them. If there's 2 or 3 turnouts together, that's where I start, and I draw lines on the track board, however you want to do it. So the first kind of step is locating the turnout on the layout, and you can see there's kind of crosshairs. I'll give you some more pictures here. Yeah, and this shows, here's the center line going through here. And then what I'm going to do is I'm going to mark here and here so I know exactly where the middle of the throw rod is, because that's where we're going to drill our hole. And I gently spike this down, maybe a couple of spikes just to hold it in place. And then I'll drill down through the center of that throw rod. That's why having that hole there is important to get that done beforehand. And then use a slightly smaller um, drill to mark the hole in the track board. So again, there's just a couple of spikes there that are holding it there temporarily. Um, And again, you can see that it's right on the center line. Uh, Boom. And I try to put the hole in the middle of the track. So I've got the closure rails, or the point rails centered between the closure rails here. And I'm just going to drill a hole through there, mark it like right there. That's a very, very good close up. And I do that in order to make sure that the location of the hole that goes below is perfect. This is really critical. If you do this, I have not had to redo anything, where in the past I was always redoing things. So if you mark it perfectly, it's going to make life easier for you later on. So once I've got it marked, I'm going to come through and use a 1/4 inch drill bit and drill the clearance hole below where the throw rod was. And I'm not just going to drill it haphazardly and just hope it's right. As you can see, um, there's uh, a dowel jig that I use. They're relatively inexpensive. This is a cheap one, and that's all I need. And I just have it set up for a 1/4 inch drill to make sure that it's going down straight and square. And if you do that, it's going to help you later on. It's not a bunch of extra work. And eventually, what's going to happen is once the BullFrog's installed, it's going to come up from below, and we'll cut this throw rod off later. But this is really what we're trying to get to, and we'll come back to that. And as you can see, I've got the turnout marked, so I can put it right back to where it wanted to go. And this is what I'm using. It's just a standard 1/4 inch uh, wood drill, and I like the type with the center brad point, because I can put it right where it needs to be, and I use that doweling jig to get that hole perfect. And again, here's the doweling jig set right on top, and I'm using my drill and just drilling down. And that way, it's going to be absolutely straight. You're not going to get any misadjustment. And it's amazing. If you go out down a little bit and it's off, you're going to be struggling with it later. And I've been over to many houses trying to fix other people's messes. This prevents it. Again, these are cheap. Anything that and you don't even need to buy this. There's other ways of making sure that you're drilling straight and true. It's critical. And again, this is what you end up with: just a 1/4 inch hole right in the center of the crosshairs. I guess it could be different dimension, but my track board is 1 inch thick, and 1/4 inch is all you need. And what I'm not doing is I'm not gouging it out and making a groove. Other people would do that, and I'm going to show you why it's a number one. You don't need to do it. It just makes a mess, and if you make a mistake, it's harder to fix. And we'll cover that at the end. And again, once the hole is drilled, I put the turnout back in over where it was, and I'll spike it in place. I do not glue track anywhere. I don't like glue really anywhere. I like to be able to move things and reuse things. And track and turnouts are expensive and hard to build. And if I may want to use this somewhere else, so I do not glue track down. If you want to keep Atlas in business, I guess that's a great idea. I don't. So anyway, this thing gets spiked back in place. Um, right there, you can see some of the spikes I use, and you don't even need that many just to hold it in place. And then once it's in, it's spiked down, ready to go. And the turnouts are the critical part. Everything else gets easier afterwards. Um, Eventually, this is kind of out of place, but this is the controller I use on top of piano wire, and it's a ball that I create for the handle, which replaces the one that Fast Track gives you. But we'll come back to that. I just wanted to show you where we're going with this. The next part, and this is the critical part, is uh, locating the screws to attach the BullFrog. And so after the hole is drilled, you can flip over the module, or you may have to go below it if the layout's already in place. And I create this little jig here, and all it is it's 80 mil styrene, and this is a 1/4 inch, same as the hole we just drilled, that goes in through the hole here, and it's based off of a paper jig that you get from Fast Track. It may be in every kit they give you, but it's on their documentation. And I just turned the paper template into this beat up piece of styrene, as you can see. And I've also got holes here so that I can locate it on either side. Um, yeah, and here's the other side of it. And that little piece of that 1/4 inch goes into the hole we just drilled. And and then I line up where the center line is going to be, and then I just drill those holes out because those are the holes that are going to hold the screws that hold the bullfrog in place. In this part, it seems like I'm going through a lot of detail here, but if you do this and you do it repetitively, it's always going to line up. You'll never have to make adjustments. And again, part of it is the great design of this bullfrog and the material they're using for that piano wire. There's something about the wire that they use that's very springy. It gives it, but it's not too tight. And in fact, when I bought these, I get extra piano wire. It's a different alloy. I don't know what it is, and it works better than anything I've ever seen. And they'll sell you extra, and it's not that much more money, and it's worth it if you end up cutting one too short. Anyway, this is a critical part. We got the holes drilled, so we're ready to install the bullfrog. And as you can see, I give a rough idea of above where the center line is, so I can align it up. It doesn't even have to be perfect, just close enough. And now because of the way I'm doing it, I can see the throw rod through that access hole, like right there. And it's through that I'm going to want to put the actuating wire through that little hole there in the throw rod that's in that hole there. So that's kind of where we're going with this. Again, another picture of that. You can see where I'm going, and I put the light on the other side. I suppose you could do it from above, so that way it's real easy to put the throw rod through. It's very easy to find, and once it's in, man, it just lines up real quick. I install these with these screws. I don't just use any screws. Whatever you use, if you don't want to use these, that's fine. My recommendation is use the same screw, use the same heads type. Like these you can't see it, but it's a Robertson, number 2 Robertson. Um, and this is all I use for all of my turnout uh, controls. And the reason is, um, if I have to go underneath and adjust something, I only have to take one tool. I don't have to guess. Is this a Phillips head? Is this a slot? Is this whatever? I know it's a number 2 Robertson, and to me, that's the best type screw. And it's just number 6. You can see it's made for wood with the large threads. So anyway, before I install it, again, this is a little trick I came up with. I, in a sense, sharpen the end of that actuating rod with a grinder. Um, it just makes it easier to find the throw rod above, and I take any burrs off, and it kind of makes it a little smaller, makes it easier. The other thing I do is in here. This goes back and forth on this actuating, and what this is I just use some. You need some wax here, and what I did is I just bought some really inexpensive uh, kids crayons and just use that, and it kind of lubricates it. The wax kind of makes it a little easier for those wood parts to go back and to rock back and forth on. Just a little trick. So here I am ready to install it. Here's the bullfrog. It's been built, obviously. The other thing notice, and we'll come back, is all 3 wires are soldered to the switch. That's critical. I'm not doing this later. Let's do that. It's so much easier to wire it at your workbench and rather than doing it underneath the layout. And at this point, I've put it through the throw rod above, and it's just hanging there. And I'm just ready to install it. And the other thing too is notice where this access hole is. That's got to always point towards the front where the control rod's going to go. So it's going to flip around in this picture, like right there. And now I just go in there with a screwdriver and just screw it in place. I've never even had to adjust these ever. They just line up. There's enough overage here. It just works perfectly, which is just a huge advantage over anything else I've done. Again, another picture. Wires are already soldered. I'm not doing it now. I've done it before. Kind of more of a picture there. And again, sometimes I'll put some tape over on the top side to hold the throw rod in the center. And going back here, notice how when I'm installing it, I want this in the center. It makes it easier, and I try to keep the throw rod centered above as well, and that's what the tape was doing there. So right there, so everything's centered, and then you can take the tape off and make it work. And this is what we're going to get to, where it's going to come up through above from a, and it's going to flip back and forth. And eventually we're going to come back with the grinder and take off the excess piano wire, obviously, but that's easy to do later on. So the next step is making the actuator rods. And this is eventually what you see is the knob with the rods, and this replaces the RC. What I use is 440 piano wire, and you can buy it threaded at one end, and you got the website there. This is where I go to get it. I think you can buy it in 12-inch and 30-inch lengths. And when you buy it though, the threads are on one end, which is fine. You're going to have to put threads at the other end because both sides have to be threaded. But that's not going to be a big problem, and I'm going to show you how we deal with that. So that's the stock material. You could try 2-56, which is less stout. Suggest you try both, see what works for you. In order to hook these, to get the control rods connected to the bottom of the pivot on the BullFrog, this is the device I use. It's an RC part that they use, obviously, in RC planes and cars to actuate control surfaces from their relays and little electric motors, etc. And I just buy these and then hook these to the BullFrogs. And then this piece here is threaded, and so the throw rod will get threaded through there, as we'll see. But that's where we're going with this. And this is where it's all set up. So this is the end result. We're going to show you a little bit more where we're going. But it gets threaded into that clevis, and then threaded up above to hold the knob. Yeah, here's some better pictures where that metal clevis is hooked into the bottom of the BullFrog. On some of these, I actually just carve this out because I don't really need this to hold the RC. This gives more clearance. And that's the 440 piano wire coming out. Again, some more pictures. There's a really good picture of that clevis, and it just you open it up and clip it into one of the holes here on the base of the BullFrog, and you just thread this in, and it's not going anywhere. Again, if it'll work in an airplane flying 100 feet up in the air, I'm sure it'll work here great. Get some more pictures. Sometimes if the alignment isn't perfectly straight, you can still use some of the control rod material and hook that up to the BullFrog, and then later on hook it up to the throw rod. You can kind of combine some of these products if you've got an area where it's got to loop around or bypass something. So you're not stuck just doing one thing. I'm just showing you a couple of alternatives. Now, once you get the rod put through, into the BullFrog, you drill a hole in the front edge, and obviously the wire is longer than what you're going to need, which is fine. But you drill that hole, and everything's always consistent. It's like 2 inches off the base for what I'm doing. And then you got to figure out how much room you push it in, figure out how much room you need, and then you cut it off. And you can't. I mean, you could use your Dremel tool, I suppose, but I'm doing enough of these that you need a specialized, in my mind, a really heavy duty, high quality, in a sense, a metal cutter. And this is the one that I use here. It's been really effective. It's not inexpensive, but it's made to cut, as you can see, piano wire, and it's really effective. And I don't use it for anything else. It stays just for this purpose here. And then here's the rod here. The other thing, I don't do any of the wiring until after the BullFrogs are in, because I don't want any of these bus wires in the way. I just mentioned that because you can see the bus wires here. And there it is, a little, little more explanation of what it looks like with the clevis. And this is ready to go in. You thread it through, hold it in place, not a big deal. And this is where you have a tight configuration where you got to do some fancy work, some adjustments. Now, before I was showing you, we had the end. We've got to put threads on the end of this piano wire. So I took it off the bench, put it in my vise, and then we got to put threads on that end. So in order to do it, you need a sense of die that's going to carve in the threads. And these are not that expensive. I think I bought this on Amazon for not a lot of money. You got to buy the handle, which in this case was an M25, I think 1 inch. And then this is the die in a sense that you buy. And this one is set for 440. And there's some videos out there that'll show you how to do this, but it's really not that hard. The most difficult part is making sure that the die is square to the rod. So you make sure the rod is in there, straight and perpendicular. And then you just work it down and carve the threads on. But watch a couple of videos on that. It's not that difficult. And this tool isn't all that much money anyway. In a sense, it's the reverse of tapping something where you're putting threads inside. Here, you're putting the threads on the outside. That's essentially what you're doing. And it's not that hard. Just you go down, carve it out, just like tapping, carve back out to get the shavings out. So once you've got the piano wire in, we got to make the control knob. So what I do is I push the rod in to its furthest point, and then I take this control knob, and I'll tell you about how to build that in a second, and figure out where I need to cut the piano wire. So that you need one of those to when you're doing the above step, which is cutting the piano wire. So again, here it's been cut off. Then I'll take it out. Then I'll put it into the vise and put the threads on, and then I'll put it back in and then put the knob on. In order to let me go back and forth. The control thing is this is just a 3/4 inch wooden ball. I think it's made out of oak. I bought it at a Hobby Lobby. I think 50 at a time. They're not that expensive. But the hard part is you got to figure out how to drill a hole into it in order to thread it onto the piano wire. And this is something I found. You drill out a hole in like a block of wood, a little bit smaller than the total diameter. Maybe that's a 1/2 inch hole, and right there. And then they put it on a small drill press, and just drill it slightly smaller than the piano wire. And I think I thread those out too. I tap those too. It's really simple to do. And I make over 100 of these, maybe 150 of these at a time. It's like if you're going to do them quick. And as you can see, I've also spray painted them. I got some Rust-Oleum, just painted them all, took them outside, spray painted everything so I don't have to come back and do it. But this is a quick way of making these control handles, if you will. You can use anything. I just like these. They're just simple balls made of 3/4 inch balls, just something to hold on to like a handle. So next step is once you got the mechanical part, we got it all hooked up. What do we do? After it's in, then I'll put the bus wires in. As you can see, everything's color coded. The bus is red and black, and then you wire the frog. And the way I do it, as you saw earlier, when I wire the switch on the frog, the frog wire, I just use green wire. I don't use anything but green wire because frogs are green, and you can't forget that. And I use 18 gauge solid for all of this. I don't use stranded. There's no reason there's just no reason to use it. I use solid 18, which is plenty. And then the other two that go to the bus wires, you can use whatever, I suppose. I just happen to have black and white, same thing, 18 solid. But notice that the black doesn't necessarily go to the black wire because it depends how the turnout is aligned and what the frog polarity is going to be. And you have to check that later. But this is the basic outline. I'm going to, the frog goes to the frog, and then I figure out which side has to be hot. And some of it is just, you got to look at it, you got to test it. Um, and as you can see here, the white wire goes to the black. So it really depends. And the other thing here in this example is here's the frog wire coming from the bullfrog. Here it is coming down from above from the frog, the lead. And then I just use a suitcase connector, what they call a suitcase connector, to put the two together. And again, when you're down below, just put the two greens together and make sure it's the correct turnout. So if you got 3 or 4 turnouts, and I've done it, make sure you're hooking up the frog wire from the bullfrog to the correct frog. Again, I've messed that up. And in order to figure out what the polarity is, you can either look at it, kind of look above and go, okay, the black wire is hot, which one it is, and then hook that up, or use a continuity tester to figure out what's hot and what the frog should be in the way the points are aligned. It's kind of you got to keep looking at it and checking it out. The other thing I do is I put one switch in and check it and make sure it's not shorting. I don't want to put 5 switches in and then come back and try to find a short. It's much, much harder. Check each turnout before moving on. And again, here's the completed module with all the wiring. A couple other things I wanted to cover here. I want to talk about some track joiners and ground throws. It's a little above and beyond, but it's still dealing with track. And what I do for my rail joiners, number one, this is not a great example. I now have staggered the joints like 2 or 3 inches apart, so it doesn't look like I'm using some sort of sectional track, even though I'm using 3-foot lengths of flex track. And I actually I make my own fish plates out of styrene and glue these in. And believe it or not, it actually holds the rail quite well, other than on curves. If it's tangent track, it works real well. On curve track, you have to do some other things. You may need rail joiners. But I like to stagger joints. That's the number one thing. If you can do it, it looks too much like a model railroad. And this is an example where just using this as an example, this is just 2 turnouts that I built. And then it's just microengineering flex track that I intersperse in there, and I pre-paint everything, and I make it so it's very difficult to figure out where the turnout begins and where does it end and where does the flex track begin. I want it to kind of flow together, so a lot of times the joints aren't next to each other. So in this example here, I think the rail ends here and then it's back here. So when the next piece comes in, you really can't tell where they come together. They're kind of spliced together. And I just think it looks better, and it takes a little more effort, not much, but to me, it kind of makes it worthwhile. And depending on your scale, I just use little strips of styrene, cut them up into lengths. If you want to get crazy, 3 foot is the standard on mainline, 2 foot, but your eye won't really know. And I just make it out of that and then pre-paint it too. A lot of times it's just easier to pre-paint it. And just use some super glue and glue it in place. Just a different idea. I've tried buying the nut bolt washers in an HO. I can't see it. I tried it and I was like, this is not worth it. The other thing too, again, this is, and I've used these are great. But one of the things with the bullfrogs I like to do, or what I try to do, if at all possible, is I try not to have the turnout controls on the layout surface. I want them below. Number one, using these are they work real well. But when you start photographing your layout, boy, these don't look very good. And when you're operating, it's one more thing where you have to, or your operators have to, reach up to throw a turnout. And it's just one more chance they have of touching the layout, hitting something, where if the controls are below, it's just easier, particularly if your hands are are busy, with a pencil or car cards, whatever. So I'm trying to replace that. That was what BullFrog does. What it also does is it forces you to um, the operators, whether the brakeman, conductor, however you set your situation up, they have to walk to the turnout to throw it, which is in reality what they always did. There aren't a bunch of little electronic switches being pushed. Also, with the bullfrogs, you can put any kind of um, call it scale switch machines in place, like we've got here. You can do whatever you want so it fits your scale, fits your period, and the prototype might have different switch stands, and you're able to do that much more readily than if you've got something that's up on top. And this is kind of the reasons why it's just nice to avoid using some of the ground uh, surface controllers. Again, they're useful, they work, I get it. I've been there. It's just giving you some other ideas. I'm not saying it's wrong, it's just that there's some different ways of doing it. Um, some other thoughts about controlling turnouts is figure out where the gaps have to go, where the insulation has to go. I've seen this so many times. I've been in layouts, and somebody just came in with a big Dremel and just went zzz, and then they never fixed it. It's just this big gaping hole, and the ballast is everywhere, and it's just a mess. And it's just one of those things is if you think ahead of time where the gaps have to go and you build those in, you don't have to come back and do this and just make a mess. Um, and so I try to avoid this whenever possible. And actually, for my insulation, I just use little pieces of styrene that I glue between the rail and then carve them down with an X-Acto and a little file, and then paint them, and they just completely disappear. You really can't tell where the insulation is. Don't use insulated rail joiners anymore for that reason. Same thing. I'm trying to avoid stuff like this. It's kind of ugly. So try to come up with different ideas. The other thing too that everybody does is they'll put the joints together like this, and then they don't backfill in with ties, and you can tell it's just a model railroad, and you can see where the sectional track ends. I just try to avoid this. I've done it, been there, done it. I just try to avoid it. Same thing here. Trying to avoid these kind of issues. Again, a couple of last things. Just want to finish up. Um, I'd mentioned about using the quarter-inch hole. One of the reasons for doing this, and I know I think on one of Tim Wearis's um, videos, he actually goes in and it almost like routes out like a groove, and you can do it, but it makes an absolute mess. Where if you just drill this quarter-inch hole, one of the advantages is it's real easy to fix because it's a standard size. Again, if it was millimeters, you could do the same thing. But because it's a standard size, like right here, this I drilled this in the wrong place, or I decided to move the turnout to the left a little bit. So I had this hole. I could have covered it up with track, but just use this as an example. I just get a quarter-inch piece of dowel. It's like 1 inch long, whatever, and just with a little hammer, just go pop, 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 put it in. You can cover it up with some paint if you want to, but suddenly it just disappears, and you're right back to where you need to be. Also, if you're going to ballast, the ballast isn't going to go down that hole either. It's just boom. But again, if you gouge it out, then you got a mess. Then you got to use spackle. It's like, no, I don't want to deal with any of that. Just to my last thoughts here, then too, is in this picture, this is the back side. And as you can see here, this is where the feeders come up. And what I want to do is I make sure that they're on the back side. I don't do them on the front side. And then I use soldering flux with acid, and I like to clean those up with alcohol. So if you use flux, that's fine in my mind, but clean them up because if you don't, the solder will continue to work on that joint, eventually break it. Again, how do I know? Because I've been there. Then once it's cleaned up, the last thing I do, I like to come in and just touch it up with some the paint I use in all of my track. And I mix up my own railroad tie brown. I use Tamiya paint, but you could use anything you want. That's kind of where we're at with all of this. So that's it. And any questions out there? I'm turning it back to you, Mr. Speed.
Of course, there's questions. Of course, we have to start at the beginning, right? So when you talked about adding the wires to the turnout, someone asked, do you add feeders to your points as well?
No, and that's a great, great, great question. I'm wondering. Let me go back. Let me see. Let me find a picture. Find a picture of a turnout. I'm getting close. Hold on. I'm sorry. I have a picture. It's going to be easier to explain it. Okay. Happens here. This isn't a great picture, but when I build my own, and it depends on the type of turnout, but when I build these with fast track, some of these are copper clad ties. So when I'm building them, these two get connected anyway. So for the turnout, the only uh, drops I have are the stock rail. The point rails will get fed from there directly. So I don't have to individually do the point rails because there's a copper clad tie in there that's connecting those two together. And these are quote unquote DC friendly. So the point rail and the closure rail or stock rail is the same polarity. So the short answer is no, but it depends on the manufacturer. If you had the old Shinichara, then you would have to do something like that.
So you're saying the points are soldered there.
Yeah, and so right in here, somewhere in here, like this is like a, it's not a perfect picture, but this would be like a copper clad tie. And so this is soldered here, and that's soldered here. And then there's a gap here. And then this is soldered to that. So when I drop a feeder from the stock rail, that point rail is automatically powered. And that's critical, and so at the end of the day, every rail has a feeder somewhere. I'm not relying upon some sort of rail joiner at all. Somehow there's a solder joint somewhere.
Cool. We had to do some math for the people who like millimeters, but I want to know, how did you pick a number 54 drill and not a number 55 or a number 53?
Yeah, I'm trying. What I did was the reason I did it is on these. Uh, this is the throw rod. The throw rod, I guess, is what we'll call it. That comes with the bullfrogs. And so I took my calipers out, and you could do it in imperial. And I love metric too. I've tried to move over to metric, but everything I can do here is I still do thousands of inches. It works. And basically, I just mic'd out that wire and figured out that the 56 was just slightly bigger. And you don't want it too tight. And they may even have instructions in there, but the 56 drill bit is enough clearance where there's just a little bit of wiggle with the wire that comes with the bullfrogs. So, and again, I fooled around with this. It wasn't just a random. I tried three or four different things at some point, and this is the one that came out best because you don't want it totally tight, but you don't want it real sloppy either.
Okay. Since you mentioned the frog juicers, do you use circuit breakers on your layout?
Um, Circuit breakers, no. And I don't use the frog juicer. I'm using just that little electric switch to throw
Correct.
the polarity. Again, frog juicers, nothing wrong with them, but this is like free. I mean, it's cheap. And so I just use the mechanical switch, and it works every time. I haven't had any trouble. And my friend Dewey, same thing. We used this thing for over a decade, never had trouble. You could use a frog juicer instead if you want, or if you have a little short frog that's only an inch long, and your engines can go over it, then you don't really even have to power the frog if you've got the right kind of locomotives. I just am very conservative, and I don't know what's going to run, and I just power everything.
Okay.
Um,
But if you short the track out there, the booster will cut it
yeah,
off, or do you put
yeah.
a circuit breaker in parts
No,
of your layout?
what I've done, I've broken my layout up into I think it's 7 or 8 different power zones. I use CVP, and so generally there's only going to be one locomotive in that district, if you will. So, and it's everything else is totally isolated. So if somebody runs the turnout, which is really normally that's about the only way it's going to short out. Somebody gets silly, me, and runs the turnout. It's going to beep, shut down until I throw the turnout. I don't add a special circuit breaker, and I've done it. It doesn't break anything. As soon as I throw the switch to the correct location, everything comes back on. But again, I put I think 7 or 8 different power zones in the layout itself, and it's only really running one engine at a time.
So at some point you said you take the excess piano wire off. Is there a
Yeah,
reason for that?
yeah, because like in this example here, when I after this is like where I've installed the bullfrog from below. So I've always got this excess piano wire. I don't want it too short. I want it to come up long. Then once it's in place, then I'll come back with the grinding wheel and get this closer so that it doesn't interfere with the cars and the engine and so forth. But I like it long so that it'll I can locate it and then I'll come back and clean this up.
Okay.
That's what I was
There's,
talking about.
there's no piano wire sticking down the bottom.
No, no, it's coming up from the bullfrog. This is the actuator rod from the bullfrog. And but I do sharpen that edge. I would have sharpened that edge with my Dremel just to make it easier to thread through the hole in the throw bar.
Okay. Next question is when you thread that rod, how do
Yeah.
you know how long to thread it?
What I do is I thread it about at least 3/4 inch, about 3/4 inch or a little less, because now in my case the ball itself is 3/4 inch, so the amount that has to be threaded, the hole isn't going through the entire ball. It's maybe 3/4 of the way. So if I thread it 3/4 of an inch or a little over half inch, 5/8, that's plenty. If you had a big ball that's an inch or inch and a half, then you might do more.
Cool. Here's an awesome question. How do you reverse the bullfrog? So when the rod is pushed in, then it's aligned for the main line. But if you need to push it in and it goes the opposite direction, is there a way to reverse them?
That's a great question. Only a crazy model railroad would ask that question, but no, that's actually come up. The way it again, I mentioned my friend Dewey Norton. I still miss him to this day. Great friend. What he did, this is one of the things he did, was he wanted all of the buttons in, if you call them the handles buttons, in if it was a mainline turnout, meaning when he
Yes.
left, everything needed to be so 50% of the time, on average, it's going to be in the right position. On average, 50% it won't. So what he did, I would not do this, but what he did, and I helped him, was he took the cable and he ran it 180 degrees. So the actuating rod came from the back side, so it can
Okay.
reverse it. So there are ways of doing it. I just don't find it's not worth it for me. But he did it because when he left, he wanted everything pushed in and know that all the turnouts are normalized. So, and that's how you do it with the control rods.
Cool. Last question. You showed some switch stands there without the manual throws on top. Do you have those animated so that they would rotate and show different
Uh,
colors?
Um, I don't. I've actually built, I think, over 100. I don't have a picture of them here with the and my prototype has like a little lantern, and I've got the little tiny jewels that sit in there, but I don't have it actuated. But I've drooled over, and I can't remember. He's a wonderful guy. I've met him from Canada. He had an S scale layout, and he had done that. I can't remember his name, and I haven't done it. I got too many turnouts, but I would love to do it. If I had an O scale layout with about 12 turnouts, I would do that. But it's hard to do in HO.
Well, Bill, that bring us to the end of the questions and the end of the show. Thank you very, very much. Um, I might ask that you repeat this whole thing for N scale so we can get those tie plates in there as well.
Okay,
Follow.
let me get my optivisors on.
Thank you very, very much.
Thanks, Speed. Thank you very much. Bye-bye.
Well, hello around the world. Good morning, good evening, good afternoon from a sunny Gold Coast, Queensland. And we're at the Gold Coast Model Train Show here this weekend. I think I'm going to come back in a little while on a mobile, and we're going to go for a bit of a walk around the train show. You can see a live Australian train show as it happens. Anyway, I shouldn't be taking up all this time here. I'll hand it back over to Speed in the bottom of the helix, and we'll speak with you soon.
Welcome back. Our next clinician is the immediate past superintendent of the 4th Division of the Pacific Northwest region of the NMRA. He models the Coal Creek Lumber Company on a beautiful S-scale layout in narrow gauge. For a peek into modeling some explosive things, please welcome Mr. Russ Segner.
Good afternoon, everyone. It's my pleasure to be with you today. I want to talk about the DuPont Dynamite factory that was at one time very active in DuPont, Washington. DuPont is midway between Tacoma, for those of you who know the area, and Olympia, the state capital of Washington. It's there, DuPont is there because in 1906, the DuPont company built a factory to manufacture dynamite. Dynamite was very important because of the need for an explosive that was safer than black powder to work in the mines and building the roads, particularly the railroads, into the Northwest. So I want to talk a little bit about DuPont. I became aware of it when one of our NMRA groups locally held a tour of the plant site and a barbecue one afternoon, and I became aware of what was remaining from the plant. This is the plant layout from an old map with the trackage as of 1950. It had extensive 3-foot narrow gauge trackage throughout the plant, as well as some standard gauge tracks operated by the Northern Pacific that access many of the areas of the plant. So here's an updated map that a friend of mine, Mike Connolly, who's really adept at map making, developed from that previous one, which shows a more clearer impression of the buildings as they're located throughout the trackage. You'll see there are 3 basic areas: a powder line area, an acid area, and a packaging area where it mentions NG, that's nitroglycerin. Weyerhaeuser Company purchased the property in 1977 because they had planned to build a access to the water for shipping logs to Japan. And when that transaction was complete, the federal government immediately changed the law with regard to shipping raw logs to Japan. So Weyerhaeuser had absolutely no reason to hold this property. About 1,000 acres, located on Puget Sound, right next to Fort Lewis McChord. So they sold it to Quadrant Corporation, which is this wholly owned subsidiary of Weyerhaeuser Company. They build housing, and in this case, they were going to build a planned unit community with a golf course, commercial center, and a small business park. What we see here is the remnant of one of the areas of the plant in the location of what we now know as Gelignite cartridge house number 1. And you can see there in the curve in the foreground some of the track that was left in place. The concrete abutments separated 2 buildings where Gelignite cartridges were loaded, and a berm surrounded those buildings on 3 sides to protect them in case one of them had an ignition. This is the location taken from a different angle, and you can see beyond the middle building there a grassy or weed covered berm, and then the red roof of that same plant. And the berm was there to deflect any explosion, to keep all of the plants, buildings from going up in one shot. There you see a good depiction of the trackage, little cart that they were using to push materials between the buildings. We'll talk about that a little bit more later. And you notice the planking between the tracks. That was to make it easier for the workmen to push those carts amongst the buildings. The site was leveled, and so there was not a huge problem rolling the carts. But during the winter and the rainy season, which is about 11 months of the year here, the planking helped make it easier to walk and maintain your footing. This is a similar location near one of the magazines, and again you can see the berm behind the locomotive there, and the building where the 3 cars being loaded, and a flat car and idler car in between. Here's a picture of a string of those flat cars. These are 20-footers, steel framed. We'll see a lot more about these in a little bit. This is after the plant's closed down, and so I'm thinking these are a string of cars here gathered as they were going to dismantle the plant. There's another shot of the mechanic chains house looking northwest. Here's a typical building, and I'm sharing this because it depicts the roofing and the siding, corrugated metal. Most of them were, except for a few that we'll see that were masonry construction. The floor in this building is at the height of the flat car. They had handled large rolls of paper products to build the dynamite cartridges, as well as 55-gallon drums of all manner of chemicals. This is another typical building. For purposes of model railroading, these are ideal structures because you can make them any length you want, and where we're forced to foreshorten everything pretty much, and the materials are pretty straightforward to build with. Here's a picture of the carpenter shop on the right, and several other buildings on the left. The buildings with the ventilators on top are probably used to house changing rooms and that sort of thing. And those ventilators are there for ventilation. It's changing the air from the outfits that people wore in the factory. Take a notice of the switch stands, pretty basic little mechanism. I've not seen one of these modeled. The trackage throughout here is 3-foot narrow gauge. Another couple of buildings, similar construction. These do not have explosives in them because there are no berms around them. This one's interesting because it's a gas station. They had a number of vehicles on site, including this little locomotive. It's a 12-ton Plymouth we'll see a lot more of. And so this is where all the vehicles were brought to gas up. I'm unclear about whether or not they operated any diesels versus gasoline. The locomotive that we have today is a diesel locomotive. This is a shot showing the carpenter shop and lube storage with the gas pump down in the distance. Let me get my cursor here. Here are the gas pumps down here. This building was used for storage of lubricants, 55-gallon drums. Here's a closer shot of the gas pumps. As you can see, the forest on this property is intermingled amongst many of the buildings at this point. And most of this has all been cleared flat for the golf course now. Here's the engine house, and this overhead gantry structure here is accessing the blacksmith shop, and then across is the laundry. Closer shot of the blacksmith shop. I want to talk a little bit about rolling stock. When the plant closed down, a great deal of the equipment, rolling stock, the flat cars, box cars, etc., were sold off to locals who used them for chicken coops and all manner of storage buildings and their other purposes. But fortunately, Weyerhaeuser retained several of the pieces of rolling stock and donated them to the museum. And this is how they looked as Weyerhaeuser left them all nicely, freshly painted in 1977-78. The boxcar is about 22 feet long. Notice the platforms on each end. The flat car on the left is steel frame. The flat car on the right is all wood frame. And that's a little 14-footer that we'll talk about. Here's an interesting piece of rolling stock. I had no idea what this was when I first got involved with the museum. I thought, well, maybe it carried big canvas bags of supplies and that sort of thing. But no, it was actually used to carry the racks of packaged dynamite sticks, the shells. Dynamite is basically encased in a cylindrical tube fashioned from paper that's cut on the diagonal. One of my friends, model railroader Jim Sable, worked in this plant in high school in the 50s, and that was one of his jobs. Once the tube is constructed, it's dipped in hot paraffin and placed in racks, sort of like gigantic milk cartons, the plastic milk crates, and slid into the racking arrangement on this car. And these were moved amongst the plant from the area where they were manufactured to the packaging facility. Here's one of the 14-footers. Jim tells me that this most likely is at the area where the shells were made. You can tell from the canopy here on this building. This little 14-footer, this is number 8. The one we worked on was number 6. This is what we found. I recall the previous photograph where the cars were donated by Weyerhaeuser. These were in really, really good shape, but this is many, many years later when I visited the plant first with that group. And this was what the little 14-footer looked like. We had no good dimensions on it, but fortunately we had enough of the building that we could measure in from each end and get an accurate dimension for the length. And then the width was pretty straightforward since we knew the gauge of the track, and so on. We had just barely enough wood to get an accurate dimension for all of the components that we had that we remanufactured on site. It's a two-axle unit with pedestals, and they basically held the car together. You can see this one is pretty, it's all there, fortunately, and it actually rotated over without any structure of the car to keep it straight. This is what it looked like many, many months later after we had rebuilt it. All of the wood was replaced. Fortunately, all of the steel was there. These various components were all in pretty good shape. We cleaned them up and took all the rust off and treated them with a preservative that converts the raw steel to something that will no longer oxidize, and replaced them on the car. It has 4 longitudinal beams that carry the car. The 2 outside ones rest on the pedestals. The 2 on the inside are suspended by cross members that rest on top of these outside beams and support the end of the car, the draft gear on each end. If you want to know anything about car building, go to work with one of the museums to restore one of these things. This is an example of a string of the steel framed flat cars. In this case, 55-gallon drums. I have no idea what's in them. Most likely these were drums filled with peanut shells or sawdust, which was used in the dynamite itself as a filler, and it emulsified all of the other components to make a handling material that was safe. Don't know the exact nature of this locomotive, but I suspect it was either compressed air or more likely a steam dummy to operate in amongst the plant. And we don't have one of these that survived. Here's a shot of several of us working on the steel framed flat car. Took all of the wood components that were there, stripped it down, cleaned all the rust off, and then fabricated the material that went on the inside of it to support the deck structure. These pieces were tapered on each edge to fit inside these steel forms, which were sort of like an inverted C. This is what the car looked like when we finished with it. Fortunately, again, we had all the steel and so on. I noticed particularly the very elaborate trucks on this car. About as basic as you can get. This is a 22-foot boxcar, and this is the same one that was in that picture that showed the donation from Weyerhaeuser. In this case, the car was pretty well beaten up. It had a broken underframe. The structural beams longitudinally here were fractured. The platforms at each end were in pretty bad shape, but basically all of it's there. In this case, it's got vertical siding and a roof that's circular or round with corrugated iron on top of it. We'll see a couple of examples of other similar cars. This is a good shot of the end platform. There was a brake wheel at each end, and often the cars were handled particularly down grade with a brakeman at the end of the car going down grade. This is an example of a car back east at one of the other DuPont plants. And again, you can see in this case, it's a sheathed siding, outside sheathed, and this is possibly plywood instead of vertical siding. This is from the same location, but notice the outside sheeting. And this would make a pretty good model for a contest, I think. and obviously repaired and kept in very, very good shape. I have no idea what's inside this. Some form of machinery, although it couldn't be that big a steel structure because it would be too heavy for this car. But they had something that was pretty bulky that needed to be stashed in this loading. This is one of them really interesting little cars. This is on one of those 14-footers, and it's a little maintenance car used throughout the plant with all kinds of tools on it, a toolbox on the end, and so on. I suspect it was used to work on maintenance of the track work. And this is one of the models that I'm going to build to finally finish my MMR. I have one of them built already. In S scale, that car, the model is about 1.25 inches long. I include this photograph because it's one of the only ones I have that shows clearly the lettering on the car. That was shot at the wharf. Talk a little bit about motive power. This is a Brookville locomotive. They built lots of these for various mining and logging operations throughout the country. That plant's back east still exists. This was a model that was left by a Weyerhaeuser and hooked onto one of those flight cars in pretty good shape. Had a Chrysler, or rather, I'm sorry, a Buick, a V8 engine in it. But notice particularly the spark arrestor mechanism here. They were quite conscious of the potential problem with sparks from locomotives. Although the Northern Pacific operated a steam locomotive inside the plant from their line that came in from the line out near what's now I-5. And they had a spot in the plant as the locomotive originally arrived where it moved under a spark arrestor, and that unit was lowered down on the stack and left on top of the locomotive as it moved throughout the plant. This is the surviving locomotive, and this is an operable unit, a 12-ton Plymouth. Was made operable by the city director of Public Works, who is still active in operating the locomotive for the museum, although he is now retired. And his name is Fred, and he and I and 3 other guys did most of the work on restoring the 2 flat cars that we'll talk about. And behind it here you see the storage building, a covered storage to protect the units that we have on display. Somebody needs to make a scratch build model out of this guy. Aristocraft makes an 18-tonner that's very similar to this, but it's much larger than this. We'll talk a little bit about the rail in a bit. It's 30-pound rail, and we have one turnout on the campus here. We would make a double-ended siding if we could, but we don't have room for it right now. I was able to source, though, a 30-pound frog from the Ardenwood folks down in California. It's another shot of the Plymouth, which shows the left side. Here's the back of it, a little clearer, and this is at the gas pumps. Here's the right side. This is at the change house, one of them actually. We can see the ventilator on top. So in operating this thing, this is a good close-up of turnout control. You notice it's actuated with the lever, obviously, and the spring holds it in either position on this side or on this side, and makes an interesting prototype. The product was shipped out, much of it by barge or freighter on Puget Sound, and this is one of the train sets going down the hill from the plant. It's about a 4.5% grade. You notice the locomotive here always on the downgrade side to avoid any runaway. Had an idler car here, and then 3 flight cars with loads on them, and a brakeman here toward the tail end. It's a color shot of this, pretty close to the same location. There is down in the creek bed here the remnants of a wrecked car that got away. I suspect the other cars and components were removed because they could be salvaged. This is now a trail that's accessed by the public. The rail could be restored, but there's several washouts on this grade. This is one of the more interesting parts of this plant site. An ocean dock on the angle because the water gets pretty deep very quickly offshore. That's why they angled them. This is the current location of the Burlington Northern from Tacoma, from Seattle to Portland, double track and so on. And what's of interest to me, amongst other things, is, well, here's an example of one of the small steamers they would operate on the Sound to carry the material. They shipped dynamite all the way up to Alaska and down into California, actually, and accessed all the ports in between. But what's interesting here for me is the tramway here, cables, carrying buckets of material up, and I'm under the impression that this was material going up and not anything was shipped down using the tram. All of that came down the rails. This is, of course, now is a fill and a concrete culvert with the track underneath. We'll see in a minute. I recall many years ago riding the train down to Portland, and I'm looking out the west side of the car, and down below me were these little tracks that came out toward the water. And I thought, wow, this must be a mine of some kind. Had no idea what it was, but it was the remnants of this trackage. This would make a great modular scene. This is on the dock, and you see the little 12-tonner and a string of cars. They've obviously collected quite a few down here, and they're maneuvering them on the dock. Notice also that the rail is on top of the planking instead of the planking in between the rails. And I've seen it both ways on docks. I think you'd worry about tripping on the darn rail as you're moving back and forth on the dock. I don't know what this rail does unless they had at one time a traveling crane on the dock, and there would have been this rail and one on the other side. There's a warehouse building here, and this is the dock for it. Up in the background here is that alignment of the BN main line to Portland. DuPont had a Navy, and this is the little tug that worked here at the plant, appropriately named DuPont. heavy fingers. This is the trackage that still exists from in its original location underneath where that trestle was, and this is now a concrete structure. 30-pound rail, not terribly common anymore. The one thing to notice on the track is that it has tie plates, and I'm not tuned into too many narrow gauge railways of the 3-foot variety that had tie plates, but this one sure did. And we have a supply of them still, and if we wanted to lay rail to extend the trackage for some reason or other, on site near the museum at the where that display rail was and the building, we've got a pile of 30-pound rail. We had a bunch of ties, but they got rid of them because they tended to collect rats. Anyway, the track went out here, and this beach is all now eroded. And so this is the end of track, and the dock that we saw would have been right out about here. So this is the display. This is when we pretty much finished the 2 cars. They're behind the train, behind the locomotive, and we had sort of a filming of the first run of these cars behind the locomotive. Okay. Anyway, this is the locomotive all finished, and I have a video here if I can get it to run. All right. Well, that's the end of my presentation. Thank you for the time together, and I'll open it to questions.
Thank you, Russ. Do you model any of this?
No, I don't, but I modeled a totally freelanced operation of fictional locations in the Northwest. But if I were to redo a layout, I'd probably do something like this, but probably in ON30, which seems to be the ideal scale for what this is. Very, very simple little operation, and this would be great for a starter for railroad for somebody who would like to do model building. You can do a lot of freelance structures to depict the types of structures shown in the various locations. Very simple track work. It's an opportunity to have some dual gauge with the standard gauge to indicate the size differences. And the equipment would be pretty straightforward to build. Like I mentioned, I have one of the little flat cars pretty well built now. I understand in order to qualify, I need to put an brake rig underneath it, which is very, very small. Fortunately, it's not N scale. I don't think you wouldn't hardly see this car if it was an N scale. But this little railroad is ideal for larger scale freelance or, modeling, and you can do it in a fairly small area.
So what kind of braking did they use on the cars?
Pardon?
What kind of braking?
Oh, these were all hand brakes with the, although the cars had air brakes, many of them had air brakes. And you notice on some of the photographs, 2 different sets of pipes for straight air and for handling the individual cars. I suspect going down grade, they would have turned up the retainers, so to speak, to retard the cars going down. Dynamite would have been fairly heavy, and you saw them stacked on those cars in the cartons. They certainly didn't want one to get away.
Was there at this location that you showed, which I assume is a museum today,
Yes.
was there any interchange with the main line?
No, the museum and where these cars are on display is well away from the actual plant. The Northern Pacific main line was easterly of the major map that I showed, maybe a quarter to a half mile, and the plant was reached from that main line up a long spur, and then headed east and west, um, where the locomotive collected at spark arrestor and went into the plant. That is the standard gauge. So there was no particular location other than that four large buildings where the materials were transloaded from the flat cars and box cars through a covered dock onto the standard gauge cars that were being shipped, where material was being shipped out by the Northern Pacific. The plant operated and built munitions for the war ever since 1906, all the way up through the Vietnam War. And I think it closed down because it just was no longer efficient. And with the change in materials used in blasting and so on.
So do other modern dynamite factories or places where they manufacture explosives, do they have rail service?
I suspect they do. The other part of this that's interesting to me is that you would have received chemicals of all kinds, acids and a variety of other caustics, etc., by rail. And so you had standard gauge tank cars coming into the site from the NP, and as well as box cars and flat cars loaded with other material.
Cool. Another question is, who was the largest buyer of this dynamite?
Well, of course, Weyerhaeuser Company itself bought an awful lot of explosives for all of their timber activities in the Northwest. But there were numerous mining areas of significance, like, for instance, Monte Cristo, up north and east of Everett, and up and down the coast, many large construction companies building roads and that sort of thing. Keep in mind that the interstate was built through this area in the early 60s. So some of the material for blasting came from there. I live in DuPont, which is a rail-served coal mining community, and they would have used quite a number of boxes of DuPont explosives. I have 2 of the boxes myself, just as collector.
So what piqued your interest to get involved with this?
Well, I went down with a friend. We went down to that barbecue, and I was just intrigued with the fact that there was narrow gauge in the Northwest, although there was narrow gauge here in Newcastle where I live. It didn't last very long here, but it lasted a long time in DuPont. And I was intrigued by the locomotive. We had a 12-ton locomotive, very small. And it just struck me that this was something that had modeling possibilities. I also had been involved in the rebuilding of standard gauge passenger cars at the Northwest Railway Museum here in Snoqualmie, which is east of where I live. And we built some 1912 rebuilt 2 passenger cars, Smith and Barney cars, for the SP&S that the museum has. They're wooden cars, wooden topsides and steel underbodies. So I spent like 7 years there, and so I had access to really good woodworking material and understood the techniques. And I commend it to anybody that's got the energy to do that, to get involved with a local museum where they always need volunteers.
Yes. Okay, a question about the factories maybe? Were the workers in the factory paid better?
I don't know that, but I suspect pretty well. It was somewhat hazardous. keep in mind the time that we're talking about, coal miners and others in hazardous occupations, timber, for instance, were not necessarily overly paid, but I think they were probably paid better than an awful lot of the menial jobs that were available.
Do you know how many people would have worked at this
It would have been
place?
several hundred.
Wow.
I couldn't get a good information on that from Jim Sable, but each of those buildings for packing material and so on would have had a crew of 4 or 5 people regularly, and I suspect they worked a couple of different shifts because they produced quite a bit of material there.
And they all would have lived in the area, right?
Pretty much, yes. People drove to the plant site, and then they'd have to walk about a half mile from the parking lot into the plant. And which, you think about that in the dead of winter, and then the snow and all that, that was just part of the routine.
So it was part of it safety, or part of it being
Well,
hidden?
safety, the plant was isolated from the general population. That's
Yes.
why it was out there in 1,000 acres. And so I think they didn't want any large population around the plant. And then once you were on the campus, you were operating in smaller buildings or smaller groups in these scattered buildings. The buildings were spaced some several hundred feet apart in most cases, except where they were loading finished material.
Cool. The at some point you had a photo, and I guess there was more than one turnout on it. And the question is, were those stub switches?
No, these were all, I didn't see any stub switches. They were all points, switch points. And we have the one example of the one turnout that's there on the display area. All of the switch points and frogs had been, they've been liberated, let's put it that way, from the remaining trackage that was there. Several chunks of rail are still on site.
And you mentioned the
Too
size
heavy
of the rail, right?
to haul away. Pardon?
You mentioned the size of the rail,
Yeah, 30 pound.
30 pounds.
The smallest standard gauge stuff I've seen is 55 pound out at the museum in Snoqualmie.
So typically you would have to buy a smaller scales rail then, right?
Oh yeah. Well, the cars were not that heavy, and the smaller rail, of course, is going to be more easily curved around the sharper curves. Although, well, on the map, it appears as some of the access to some of the buildings were around fairly tight curves.
Did the workers wear any protective equipment
Yes.
things?
Yes, they all had work gear that they wore when they were working in the buildings, and they would change into those at the beginning of shift and hang their clothing up in the change house or change room, and then retrieve their going home clothing at the end of the day. I'm not sure whether they had showers there. I know that all of the coal mines typically had showers, but I suspect in many cases they did, where they were working around chemicals.
And the rail side of things, they were also wearing something special? The
No, I don't think
engineer
the
and the
locomotive
switchman.
crews coming from the NP were outfitted with any special outfit. Not, for instance, respirators or anything like that. Not aware of the use of respirators in this plant.
And did they have,
in the 50s and 60s? They might have.
okay, did they have equipment available? I mean, like a fire extinguisher?
Oh, I'm sure
somewhere?
they had They had designated places for fire suppression equipment and so on. But let's face it, in a dynamite factory, if you have anything go off, a lot of it goes off.
Correct.
And so you really need a sponge and a wheelbarrow to clean up afterward.
I remember when we went to the grain elevator tour during the convention here, they have these chlorine rooms for when something there um, sets on fire, because it's another place where if a small fire starts, then it turns into a big fire quickly.
Oh yeah, well, elevators are very dangerous because of the dust,
Yes.
similar to coal mines. I don't think I'm not aware of any big bad accidents at DuPont. Um, it, I suspect if there was one, they would have been pretty well written up.
So this MMR business, how many certificates do you already have?
Oh, I've got 8 or so. The only one I'm missing is the rolling stock.
And you're
And
missing
I
this one
keep
car?
getting, pardon?
And you're missing one car?
No, I've got one car done, and I need
Okay.
to finish the other 3. So I built a fire car from an old pickle car, actually, with a wooden tank on it, and I've turned it into a fire car for my SN3 layout.
So what's the plan for the other 3?
Well, I've got this one little 9-footer or 14-footer pretty much done, except for the steel work on it. It needs end railings and like I mentioned, the underbody, that is the brake rigging, and then that's finished. And then I'm thinking of building a similar car, but with that work apparatus on it, the canopy and toolbox and all of that, all the junk that was on it, make it kind of a neat little model. That one almost begs to be modeled in a larger scale.
Yes.
As does that outside framed boxcar. I really like that one. That would be kind of fun to build.
You could also build that engine and put it in as a car.
Well, I've seen some beautifully done small engines like this done with styrene.
Mm-hmm.
And although you could build it out of brass, but styrene seems to be the preferred method here. We have a local fellow that lives in Gig Harbor, Don Rose, who's routinely runs away with Best of Show at the narrow gauge conventions and symposiums that we have here. And it's all styrene.
Yeah, it's different when you build something to get it done and get it merited versus competing with someone else. That's another
Yeah.
level of commitment.
Well, the other group that we have out here that's pretty strong is the logging modelers. And many of them are incredibly skilled model builders.
Yeah,
And that is almost always scratch built.
well, sir, that's the extent of the questions, unless someone puts something new in. And that was a very, very nice presentation as well.
Well, thank you.
I was not going to attempt any of this because I always like to have an animation thing as part of a scene, and I think explosives I should probably stay away from.
Yeah. Well, Larry, are you familiar with Larry McLean in Australia?
Yes, yes.
Builds beautiful, beautiful animation situations.
He actually uploaded a video either this morning or late last night into the interchange about operating where the gate opens and the blue flag comes up. And
I'll have one model from him that he gave me when he was here in 2012, of a blacksmith with the anvil and
yes,
all of that, and it functions. Very, very clever.
Well, one day we will convince him to join us here on NMRAx.
Oh,
he actually modeled the whole crew of us, with me sitting in a helix,
yeah,
and Martin with his hand, and Corey and Brad behind the computer, and we're all on a flat car moving through his layout.
Yeah, it's incredible. Well, I'm sorry, at the very last slide that I have there was animated, and for some reason worked every time until today. Just as I had the locomotive coming out with the 2 cars on it. And we had a big grand opening of that with, And believe me, the people always will show up at a grand opening like that are the political people. So I had 10 different bigwigs of one kind or another on top of those cars trying to maintain their balance as the car moved down that track.
Hey, all you could have said is you're more than 30 pounds. Sorry, you can't go.
Yeah. Yeah, indeed. It's a very interesting group, and the little museum is open 3 days a week, and it's reachable by just Google DuPont, Washington, and they've got a link on their website there. They're very, very welcoming.
Do you know which 3 days?
It's usually Thursday, Friday, and Saturday.
Well, sir, thank you very, very much.
Well, thank you.
We will hopefully see you again. So maybe a narrow gauge layout presented to the whole world. And,
Sure could.
Thank you very much.
All right, thank you.
Welcome back. I'm Speed at the bottom of the helix. We are in the last segment of today's September update of NMRAx, and our next clinician, MMR number 177, Gerry Hopkins, a fellow of the NMRA with the most NMRAx clinics ever. So please watch how Gerry shows us more layouts, part number 10.
diesel.
Well, Gerry, thank you for a very, very, very awesome clinic again. Layouts after layouts after layouts. Want to thank you everybody for hanging out with us at NMRAx. If you do know of someone like yourself who would like to present a clinic here, we do need to hear from you at nmrax@nmra.org because we are running short on clinicians going to the end of the year. So please, please let us know. Now I want to hand it over to the other side of the planet where Martin Jenkins is going to give us a live tour of miniature trains on the coast. Martin, it's all yours.
G'day everyone, here we are, live at the miniature trains on the coast, and look who we met down here. It's Jeff. Say g'day, Jeff.
G'day, Jeff.
See, saying g'day, Jeff. So we've got a few layouts here. It's only a small show, but we'll go for a bit of a wander around. So let's have a look. We've got Jeff's layout down here at the moment. Then we've got the Action Model Railway Club over the other side. We've got the Logan Model Railway Club here with Walloon. There's some desperados over in the back. I believe we might even bump into Brad's dad. So we'll go and have a look at that in a minute. But over here on the stage, let's have a little look. We've got the Miniature Train Club here, who are our hosts, and they've got a little N-scale T-track layout happening. So we can see, give a wave to everybody. You're live at the moment. Make out that you're awake. Yeah, I know, sleeping beauty on the end. Well, sleeping on the end. I wouldn't go about beauty, but anyway. Oh, yeah, he's casting aspersions now. Say g'day to everybody in YouTube land. We're actually live at the moment. So John's here, and we've got his layout up and running. Another T-track N-scale. This T-track N-scale stuff is proving a bit big. There's someone selling wood over here, sticks and bits and pieces. So let's go down this way and see if we can bump into a few people. So we got the nerve centre of Walloon at the back here, which is a lovely little Queensland layout. So let me get through this bumpy video. I'll get down off the stage there, and here we go. As you can see, there's much negotiation happening beyond the layout, and not much running. G'day, mate. How are you? Say g'day to everyone on NMRAx, because you're live at the moment. We're live on the radio.
Excellent. I can't run anything for you at the moment. I was late getting here, so I'm just trying to sit down.
Oh, they just got here. They're late setting up. We'll look over here, and who've we got?
There you go, Martin.
Say g'day to everyone on NMRAx, Graham.
Hello, everybody.
And Tony's hiding behind the corner. We can't put Tony on. He's in the witness protection program, so he can't go on. But let's have a look at a few trains on here. The race happening here. So as you can see, N-scale's pretty big here. Let's have a look back on the layouts from down here. I haven't been kicked off here yet, so I must still be going. And we come around the corner here, and let's have a little look at High Country. We've got Mark's running around here, so we might be able to get him to say g'day to everyone on NMRAx.
G'day, everyone on NMRAx.
There you go. See, they're a friendly lot down here.
Yeah.
So here we go. Banff National Park, done by the Logan District Model Railway Club. So another spectacular little layout.
Big Chief 2D's coming around.
Big Chief
2D.
2D.
Yeah, Big Chief 2D's coming around.
Okay. Oh, here he comes.
See if you can see Big Teeth 2D.
Oh, there you go. Well, we'll keep moving down here and we'll see who we got next. Now, this is a lovely little Queensland layout here. So this is what Queensland Railways, Michelle would recognise those cars. But anyway, let's see what we've got down here. Everything on here is scratch built. So, yeah, but a lovely little layout. And hiding down here is Peter from the Logan District Model Railway Club. Say to everyone on say good day to everyone on NMRAx.
Yeah.
It's live
Hey
at the moment.
How are you today? We're having great fun here.
Yep. So we're running trains in Queensland.
Yep.
On a Queensland layout.
Yep.
So Michelle should be able to recognise some of those cars that went past. And we got some cattle, and it looks like it's loaded because they're all in there moving. So anyway, we shall keep moving. Take care, Pete. We'll keep moving. Jeff's over there, hiding again. Now this is the most inappropriately named club in Queensland. It's called the Action Model Railway Club. But every time I go around there, they're sleeping. And I reckon it's the Inaction Model Railway Club is more to the. Is that correct? Oh, the Premium Club, they say. Well, say good day to everyone on NMRAx. Well, they've gone out in an industrial dispute, I suppose. Well, they had British Railway running here, but they've been replaced by a bus replacement service, so they're not actually running anymore. Anyway, let's keep moving around here and see what else we can find. Oh. There's some remote control vehicles outside, which we're going to go and have a look later, but it looks like one of them's taken a wrong turn and ended up in the hall. But anyway, we'll keep moving. Yeah. Here's the retailers. You don't really want to go down there to look at stuff that you buy. Oh, look, there's someone's waving to us, so he's probably watching at the moment. But anyway, here's Cole. He's always got bargains of the century. Yeah, there he goes. See, he talks like that to me all the time. So we'll go outside and we've got tinkering tools. We've got all the things that you could want, and screwdrivers, tweezers, pliers. We'll keep moving. Okay. Now we got another group down here where we've got little Melbourne tram layout, which we'll have a quick look at. So that's Bella, which is oh, look out, there's a couple of victims sitting over in the corner here. Say good day to everyone in NMRAx that's live at the moment. We've got a lovely little HO Queensland layout here. Over the back here, say good day to everyone on NMRAx. It's live at the moment. We got, as you can see, N scale is big. It's huge. But lovely little layout here. Lots of detail in there within scale. Have a little look at the cafe. Anyhow, we'll keep moving. We're going to have a look at the next room. And the next room is just one layout from one club. And it's the Ipswich Model Railway Club. So say good day to everybody in NMRAx land. See, they're a responsive mob. Sometimes. Oh, there's a wave from the... Oh, Richard's here. Hello, Richard. How are we?
Happy little pig in mud.
Good. He's sitting on his chair, running trains. What more could you want?
Yeah, it hasn't fallen over.
What, the chair or the train?
The train.
Okay. We don't worry if the chair falls over, is it?
Yeah. Alvin, we like to give the dogs a pick.
But a lovely layout, except we had to put them in a room all on their own because they don't play well with others. So they had to be contained in their own room.
What's wrong with competition?
Yeah. Okay, let's head out of here and keep moving. We got another room round here. We got the canteen. Coles trains. Another lovely little layout here. More in scale, just in case you didn't have any more, you needed more in scale. You always need more in scale. And we'll keep moving down here. John's going flat out over in the corner here, making a rip-roaring sale. And we'll go back out and we'll be at the front door. That'll be about it. Like I said, it's only a small show. NMRA stand. So, and front door with the raffle prizes. What more could you want? The most important thing is there's some more remote control vehicles. So let's go and have a look and see if we can find them. Most important thing, the coffee vendor. So they're here.
I won't be here if I can.
So let's go down here now and
Can you get a D11 further? No, a D. They do a D10. Don't do D11s. Don't do a D11. Oh, they have one now. Oh, is it 110 scheme? Oh, it's a 110. That's right. 110 kilos? Yeah. Or that'd be where you, if you want to buy one of them, where you spend on that? Speed that.
right, so there's even more vehicles down here. Oh, looks like they've got a convoy happening. Let's go around the corner here. Look, they've even brought their own buckies. Hey, it's a bit smaller than buckies. There you go. You can even smell the diesel. So there, look, all sitting down, relaxing over the back there. Say good day to everyone on NMRAx. It's live at the moment. So these are the Brisbane RC Truck Club. They've got all sorts of bits and pieces here. Anyway, I think it's about time I probably went and got some something to eat. It's about morning tea time. I'm starting to feel peckish. So is anyone still there? Yeah. You're around, are you? Well, there's a little look of the show. I don't know how well that went. See if I can change the camera around. There you go. Now you can see me. Now, I think I got to. I think I got to go over here and spend some money with this guy, because my coffee cup suddenly developed a leak. It's got a big hole in the top and it evaporates.
Can you ask him what is the story behind the coffee?
I don't know. He hasn't told me any story behind the coffee, but apparently there's a story behind the coffee. So I don't know what it is. I'll find out and get back to you.
Thank you.
So that's about our trip around the train show. Let me see if I can change this camera around because I can't hear you when you're. There we go. Now I can hear you.
For showing us around, and I guess we'll finish up the show. Did you want to have a quick chat to the division there at the show for the NMRAx?
Well, this is Division 1 here with the NMRA in Queensland, and not for everyone to forget, next week is our convention down in Sydney at Rose Hill. So yeah, we look forward to seeing a lot of you there.
Perfect. Thanks, Martin, and we'll wrap up the show with that.
See you then. Bye.